So welcome to this latest video 162 Math, and in this video we'll be going over some GCSE Maths higher exam questions related to simultaneous equations where one is linear and where one is non-linear. Now, as always, I'll include a copy of the questions that we go through in this video in a link in the description below, and I'll also include a lesson that goes over this topic in more detail. Now, before we get started working through some questions, let's just have a quick overview over what it is you need to revise for this particular topic. Now, I will include a lesson link in the description below which goes through this topic right from the very basics. So if you're unsure about this topic, I strongly recommend you watch that video just so that all of what I'm about to mention makes a little bit more sense. So the first thing you need to be aware of and be comfortable with is working with simultaneous equations where you've got two linear equations. This is the basics of simultaneous equations, so it's really important that you do know how to work with those. The next thing is rearranging equations. So again, be familiar, know how to do that and when to do that. Obviously, with simultaneous equations, there are two main methods you can use. There is the substitution method, which tends to be used for this particular topic, where one equation is linear and the other is non-linear. Whereas when you've got two linear equations, I would probably assume that you would tend to go for the elimination method, where you're trying to get x's and y's on one side and the numbers on the other, and trying to get the same quantity of x's or y's. However, you can still use the substitution method for two linear equations when you've got one letter as the subject in both the two equations. So again, completely valid, but you need to be aware of those two methods. The next thing, particularly with this, is going to be factorizing and solving quadratics. So it's really important that you're able to solve factorize quadratics both with a single x squared and multiple x squareds, and also know how to solve quadratics in terms of via factorizing, but also by using the quadratic formula, which can creep in this particular topic. You also need to know how to solve equations graphically. So again, how you do that is you plot both equations, and the solution is the coordinates of where the curves and the lines intersect. So you're looking for those intersection points, and the coordinates will be your solutions to the equations. And again, that kind of goes into whenever you see the word intersection, always try and think simultaneous equations. And again, that goes all the way up to AS level and A level as well. The next thing is presentation. Obviously, these questions do carry quite a lot of marks, so it's really important that you present your work neatly and you know exactly how to spot a mistake, because it is very easy to make a mistake when working through this. So if you can try and create a sort of template on how you're going to structure your solutions, then that's going to be absolutely great in terms of maximizing your marks. And obviously the next thing is substitution, which I know is already mentioned, but again, it's really important that you know and be comfortable with substitution, not only with substituting numbers, but also substituting algebraic expressions into new equations. Now again, a little reminder, if you want an access to these questions, all you need to do is just simply click on the link in the description below, and I strongly recommend you have attempted these questions before continuing watching this video, just so you can test your understanding and know how much of this topic you get. So looking at question 1, it says here are two simultaneous equations, and it says is x equals 2.5 and y equals 3.5 as solutions to these equations. Tick a box and explain how you know. Now for this, again, try and avoid ticking a box first without doing the working out. Always do your working out first and then tick the box. So for this, all we need to do is just simply pick one of the equations. So I'm going to go for the top one, and then all I'm going to do is substitute these two numbers to see if it does equal 4. So here we've got 3 lots of 2.5 plus 1 lot of y, which is 3.5, and we want to know what that equals. So here we've got 3 times 2.5 is 7.5 plus 3.5, which equals 11, and as you can see, that's not 4. So then, is the solution correct? No, it is not. Moving on to question 2, it says solve the simultaneous equation. You must show you're working out. So for this, we can see that we've got two linear equations. We then check and see, have we got the same number of x's, the same number of y's? Well, I've got the same number of y's. The signs are different, so then we add the two equations together. So here, 2x plus 3x is 5x. The y's cancel out, and 8 plus 22 is 30. So 5x equals 30, so x equals 6. So then using 2x minus y equals 8, and knowing that x equals 6, I've got 12 minus y equals 8, so y equals 4. So I also need to write down my values of 6 and 4. So then moving on to question 3, it says solve the simultaneous equations of x plus y equals 9 and y equals 2x minus 3. Now there's a couple of ways in which you could answer this particular question. You could either do a bit of rearranging to get x's and y's on one side, or you could make y the subject in both the equations and make the two equations equal to each other and then solve it for x. So it's entirely up to you which method you're going to go for. Now for this I'm going to use the substitution method. So where I see a y, I'm going to swap it with 2x minus 3. So here I've got x plus, instead of writing y, I'm going to write 2x minus 3, and that equals 9. And again, where I've taken that from is I've taken it from here. So then simplifying this, I end up with 3x minus 3 equals 9. So 3x equals 12, so x equals 4. So then using y equals 2x minus 3, I know x equals 4, so that's going to be 8 minus 3. So y equals 5, and there are my two answers. So in the answers section, I can then just write 4 and 5. Moving on to question 4, it says solve the simultaneous equation. So again, it must show you working out, so not guess. Basically, do not use trial improvement. Basically means you can't guess. So you need to show you working out. So for this, I've got the same number of y's and the same sign, so I take away the two equations. Now here I'm going to end up with negatives, so if you're not happy with negatives, then just flip the two equations around. So you'd have 8x minus 3y equals 10, and 2x plus minus 3y equals 1. And then you won't be dealing with any negatives, but I'm just going to leave it as it is. So here I end up with minus 6x, y's cancel out, and here I end up with minus 9. So x is going to equal minus 9 over minus 6, which is 3 over 2, which is 1.5. Again, depending on whether you want to work with fractions or decimals, it's entirely up to you. So then picking one of the equations, so let's go for 2x minus 3y equals 1. I'm going to use the decimal equivalent, so I know that x equals 1.5. So this is going to be 3 minus 3y equals 1. So then minus 3y is going to equal minus 2. And then y is going to equal minus 2 divided by minus 3, which is 2/3. So again, you can either write as a decimal, but don't forget the reoccurring, or you can write as fractions. So it's entirely up to you which one you go for. Moving on to question 5, it says that in a coffee shop, 3 cups of coffee and 1 muffin cost £10.45, and 3 cups of coffee and 4 muffins cost £22.55. And it says work out the cost of a cup of coffee and cost of a muffin. So let me just move back to see what we can see. So first things first, what we need to do is write the two orders algebraically. Now for this, we've got 2c plus m equals 10.45. And we've got 3c plus 4m equals 22.55. So again, what I want to do is make the m's or the c's the same. I can notice that if I make the m's the same, I need to multiply this one by 4. So I've got 4 times 2c, which is 8c, plus 4m, and then 4 times £10.45 is going to be £41.80. And then if I write the second order, 3c plus 4m equals £22.55. So now I've got the same number of m's, they're both the same sign, so I take away the two equations. So here I end up with 5c, m's cancel out, and £41.80, take away £22.55, gives me an answer of £19.25. So 5 cups of coffee cost £19.25. Then 1 cup of coffee is going to be 19.25 divided by 5, which is £3.85. So then using one of the orders, I'm going to go for this top one here. So here I've got 2c plus m equals £10.45. Well, if c is £3.85, then this is going to equal 2 times that, and 2 times £3.85 is £7.70. So then if I take away the £7.50 from £10.45, I get an answer of m equals £2.75. So then all that's left for me to then do is just write down the answer. So here it's £3.85 and £2.75. So then moving on to question 6, it says solve the simultaneous equation. So here we've got our first example of one linear equation and one non-linear equation. It says do not use trial improvement, which basically means you can't guess and you've got to show you're working out, and it is worth 5 marks. So for this particular question, what we need to do is with the linear equation, we need to make one letter the subject. Now we've got one letter the subject in the quadratic equation, or the non-linear equation I should say. So what I'm going to do is I'm going to swap y with this particular equation, because in both the equations the x value and the y values are going to be exactly the same. So if I then use this equation, and instead of using the y, I'm going to swap that with this. So what I end up with is x plus, instead of writing y, I'm going to write x squared plus 2, and that equals 4. So then simplifying the left hand side, I get x squared plus x plus 2 equals 4. Take the 4 over because it's starting to look quadratic, and solve a quadratic I need to make it equal to 0. Then I want to think about solving the quadratic, so I'm going to go for factorize because this does factorize. So I've got x equals 0, and my numbers are going to be plus 2 and minus 1. So that means that the solutions are going to be x equals minus 2 or positive 1. So then when x equals minus 2, then using x plus y, because that's the easiest equation I've got, I then get a y value of minus 6, of 6 rather. And then when x is equal to 1, then using x plus y equals 4, y is going to give me a value of 3. So then my answers for this are going to be when x is minus 2, y is positive 6, and when x is 1, y is going to equal 3. Then moving on to question 7, it says on the grid below, draw the graphs of y equals 3x minus 2 and x plus y equals 4. And then it says hence or otherwise solve the simultaneous equation. So for this, what I need to do is draw a set of axes. So let me just quickly do that now. And there we go. So all that's left for me to do is then just label it. So here I've got y and I've got x. So if I just use 1 square equals 1, and you don't need to go for all of them. So we could add them as we go along. So here, if I draw a table of values for y equals 3x minus 2. So again, picking 3 smallish numbers. So I'm going to go for 0, 1, 2. So when x equals 0, 3 times 0 is 0, minus 2 is minus 2. 3 times 1 is 3, take away 2 is 1. And 3 times 2 is 6, take away 2 is 4. So then plotting this, I've got 0 minus 2, which is there, 1, 1, which is here, and 2, 4, which is here. So all I then need to do is draw a straight line going through those points. And again, on the computer is extremely annoying and frustrating as it takes a while, so just bear with me. And when you're drawing lines on graphs, just try and go to each of the ends of the grid that you've been given. So this is y equals 3x minus 2. So next what I need to do is then plot x plus y equals 4. Well, for this, when x equals 0, y equals 4, and when y equals 0, x equals 4. So the coordinates there are going to be 0, 4, 0, 0, 4, and 4, 0. So all that's left for me to then do is draw a line connecting those two. And what I'm looking for is where the points intersect. Like so. And so all I then need to do is write down the coordinates of this point here, which look like 1.5 and 2.5. So 1.5 and 2.5. Now if I wanted to solve this algebraically, then again all I need to do here is just swap the 3x minus 2 and replace that with where I see a y in the other equation. So here I've got x plus, instead of writing y, I'm going to write 3x minus 2, and that equals 4. So I've got 4x minus 2 equals 4, so 4x equals 6. So x equals 6 over 4, which is 3 over 2, which equals 1.5. So then, using x plus y equals 4, x equals 1.5, 1.5 plus y equals 4, so y equals 2.5. And as you can see there, I end up with the exact same answers. Then moving on to our last question, it says that a straight line has the equation of y equals 2x minus 1 and a circle has the equation of x squared plus y squared equals 13. Solve these simultaneous equations to find any point of the intersection of the line and the circle. You must show you're working. So again, intersection point basically means simultaneous equations. In this question, you don't need to know about that fact because it tells you that in itself. And again, it's worth 5 marks. So here what I'm going to do is I've got y the subject in my linear. So what I'm going to then do is wherever I see a y in the non-linear, I'm going to swap it with 2x minus 1. So looking at the equation of a circle, it's x squared plus. Now instead of writing y, I'm going to write 2x minus 1. And that's, don't forget the square, and that equals 13. So then expanding the brackets out, I get 2x minus 1, 2x minus 1 equals 13. So x squared plus, and it's going to be 4x squared minus 4x plus 1 equals 13. So then end up with 5x squared minus 4x plus 1 equals 13, and then making it equal to 0. 5x squared minus 4x minus 12 equals 0. So then from this, what I then want to do is then solve this quadratic. Now I can either solve this by factorising or by using the quadratic formula, and it doesn't really matter which one you go for. But again, if you did factorise, should have 5x plus 6 and x minus 2 equals 0. So x is going to equal minus 6 over 5 or positive 2. So then if you did the quadratic formula, I should end up with the same two values. So when x equals minus 6/5, then again what I'm going to be using is the linear equation of y equals 2x minus 1. So y equals 2 times minus 6 over 5 minus 1, which gives me a y value of minus 17 over 5. Then when x equals 2, then again using y equals 2x minus 1, y is going to equal 2 times 2, which is 4, take away 1, which is 3. So my second set of coordinates are 2 and 3. So all that's left for me to then do is just write down the values, and I can write them in any order in which then I've got those as my answers. Now sometimes you might, whenever it mentions intersection points, you might want to write your answer as coordinates, but in this it's already given me the template, so there we go.